will be discussing about the first module, DC circuits. Now, in the previous lecture, I have given a very brief introduction about basic electrical engineering, the subject, the various objectives set for the subject, the various course outcome set for the subject, and the syllabus of the subject. What are the different modules that I have discussed in the previous lecture? In this lecture, I will start module number 1, that is DC circuits. So let's begin. So firstly, I will give introduction about basic electrical engineering, we can say, or the various terminologies related with basic electrical engineering. So first one is circuit. So what is circuit? A circuit is a closed conducting path through which an electric current either flows or is intended to flow. So what is a circuit? It is actually nothing but a closed path in which current flows. Current will flow only when the path is closed, otherwise current will not flow. So the closed path in which current is flowing, that will be known as circuit. Okay. Next is linear circuit. Linear circuit, before describing linear circuit, I will describe what is linear element. So a linear element is an element whose property does not change with change in voltage or current. Okay, whose property does not change with change in voltage and current, that is a constant value. That have a constant value for a particular voltage and current. So those type of elements are called linear elements. Okay. Now, the circuit consisting of linear elements will be known as linear circuits. One example of linear circuit or linear element is a resistor. A resistor is a linear element. The property of resistor does not vary with change in voltage and current. It gives a constant curve. Next is non-linear circuit. So non-linear circuit, before going to non-linear circuit, I will explain about what is non-linear element. Non-linear element is such an element whose property changes with change in voltage and current. Okay, so change in voltage and current will be there, so the property of the element will also be changing. That element is known as non-linear element, and the circuit consisting of non-linear element will be known as non-linear circuit. This type of circuit, we will not get a straight curve. We will get curving varying in some manner, but it will not be a straight line. Next is bilateral circuit. Again, before going to bilateral circuit, I will describe what is bilateral element. A bilateral circuit, a bilateral element is an element whose property does not change with the change in the side. It does not change with change in direction. For example, a resistor. If we connect a resistor, suppose there is a resistor, it is having two terminals A and B. Okay, so initially we are connecting the resistor A and B. Current flows from A to B. Now what we do for the next case, we will reverse the terminals. We will make B and A. So current is flowing from B to A. So it will be seen that there is no change in property of the element when the sides of the element changes. So those type of elements will be known as bilateral elements. Bi means two and lateral means side. So the current will be flowing, or the property will remain same in either direction. Okay, so one such example I gave you, it is resistor whose property does not change with change in direction of the terminals. And the circuit consisting of bilateral elements will be known as bilateral circuits. Now unilateral circuit. Uni means one, lateral means side. Okay, so that unilateral element is what? It is such an element whose property changes with change in direction. Suppose one example of this is a diode. All of us know that diode conducts only in one direction when it is forward bias, then only a diode conducts. That means what? If we change the terminals P and N, if we reverse the terminal, then there will be no current flowing in the circuit. what? It conducts only in one direction. So its property changes when the direction of the terminals are changed. So those type of elements are known as unilateral elements. And the circuit consisting of unilateral element will be known as unilateral circuit. So one example, as I said, is a diode. Now what is passive network? Passive network is such a network which have its own voltage source or which have its own power source. That type of a circuit will be known as passive circuit or passive network. Active also. Passive means it is not having its own voltage source. Active means it is having its own voltage source. So passive network is one in which there is no source of EMF present, and active network is one in which the voltage source is present or the power source is present. The circuit is having its own EMF source or it's having its own power source. Okay. Now what is node? A node is nothing but a junction where different elements meet or where different branches meet. Okay, node is nothing, it is a junction. It is a junction where all the different elements of the circuits are connected. Suppose one resistor is connected, one inductor is connected, one capacitor is connected at a single point. That point will be known as node. Next is branch. So in a circuit there can be more than one number of nodes. So the branch is the element connecting two nodes. The element connecting any two nodes will be known as branch. Next is dependent sources. Dependent sources, as the name suggests dependent. It depends on something, but if it depends on one, such a source whose properties depends on some other quantity of the circuit. Okay, such a source whose property depends on some other elements of the circuit, some other quantity of the circuit like current, voltage. Those type of sources are known as dependent sources. So those were the terminologies which will be required throughout the entire course. So it was important to discuss the terminologies. So I have discussed the terminologies. Now I will move to the next topic, that is Kirchhoff's law. All of you must have studied Kirchhoff's law in your basic class, high secondary level. Here I will give a very brief introduction about Kirchhoff's law. So Kirchhoff's law, how many laws are there? There are two laws. Okay. Why are they useful? They are useful in determining the equivalent resistance of a complicated network and conductors and for calculating the currents flowing in various conductors. The two laws are Kirchhoff's point law or Kirchhoff's current law. It is also abbreviated as KCL. Next is Kirchhoff's mesh law or Kirchhoff's voltage law. It is abbreviated as KVL. So first I will discuss about KCL, that is Kirchhoff's point law or current law. So in any electrical network, the algebraic sum of currents meeting at a point or junction is zero. What does it say? That in any circuit, in any electrical network, the sum of the currents meeting at a point will be zero. That means meeting at a point, where will the current meet? The current will meet at a node or at a junction. So the different currents coming to the junction, the sum of all those currents will be equal to 0. I will give an example. Suppose this is a node A, a junction A, where these different currents are meeting. Okay, so at this node A, I1 is coming, I2 is leaving, I3 is leaving, I4 is coming, and I5 is leaving. Okay, so we take the current coming to the node as positive and the currents leaving the node as negative. So this will be I1, since it is coming, it will become positive. I2, it is leaving, so it will become negative. I3 is leaving, so it is negative. I4 is coming, so it is positive, and I5 is leaving, so it is negative. So algebraic sum of all these currents will be equal to 0. See, I1 plus minus I2 is equal plus minus I3 plus I4 plus minus I5 is equal to 0. This is Kirchhoff's law. Now if I solve this, I will get I1 plus I4 is equal to I2 plus I3 plus I5. I will get this equation. Now what is I1 and I4? I1 and I4. I1 and I4 are the incoming currents, and I2, I3, I5 are the outgoing currents. So the incoming currents is equal to outgoing currents. This way also we can state Kirchhoff's law. So this is how Kirchhoff's law is applied. The current coming to the node is taken as positive, the current leaving the node is taken as negative. Next is Kirchhoff's mesh law or voltage law. What does it say? It says that the algebraic sum of products of currents and resistances in each of the conductor in any closed path or mesh in a network plus the algebraic sum of the EMFs in that path is 0. The drops, the EMF, the product of current and resistance, that will give what? Voltage or voltage drop. So the sum of all the voltage drops and the voltage of the EMF source present, the sum of all those things that are present in a single network, in a single mesh, will be equal to 0. In other words, we can say summation of IR. Summation of I means current, IR means resistance. So whatever be the number of current, whatever be the number of resistance, multiplication of those means we will find out single drop of all the elements. Summation of all those drop plus the summation of the EMFs present, that total sum will be equal to 0. Suppose if we consider this network, there is no there is no voltage source present. So if there is no voltage source present, this network is nothing but it is a passive network because there is no voltage source present. Okay. So what are the various drops? Suppose we are going in counterclockwise direction. Okay? We are following this direction. So from minus to plus, V8 is what? It is increasing, it is rising, the potential is rising, so it will be plus V8, again minus to plus V5, again minus to plus V6, then again minus to plus V7. The sum of all these voltages will be equal to 0. Okay, V5 plus V6 plus V7 plus V8 is equal to 0. Next, sum of voltages if I take in the counterclockwise direction. So suppose I am taking from V8. So it's from plus to minus, it is decreasing. Drop in potential is there, so it will be minus V8. Okay, minus V8. Then again plus to minus, drop in potential, so it will be minus V7. Again plus to minus, so it will be minus V6. And again here it is from plus to minus, so it is minus of V5. The sum of all this current will be, voltages will be equal to 0. So this way also we can write if we are taking in the counterclockwise direction. This way also we can write if we are taking in the clockwise direction. Okay, so now this is important, how to determine the voltage direction. See, if current, if the direction is this, so the potential is rising from minus to plus, so the E will be plus E. If the direction is this, but the terminals are, see, the terminals are altered, so it will be minus. Again here from plus to minus, drop in potential, so it is minus. From, see, the motion is this, so it is from minus to plus, so it will be plus. So this way we consider the voltage sign. Now another method which is very important in solution of the various DC networks. There are various methods, there are various laws and various theorems derived which are used for solving DC network. Now nodal analysis is a technique of solving DC network. This is nothing but it is the application of Kirchhoff's current law. Node, since it considers with node, see, suppose I take this network. Okay, how many nodes are there? 1, 2 and 3. Node 1, node 2, node 3. But always in a circuit we consider this node as the reference node. Reference node means the value of voltage potential of this particular node is taken as 0. So if we consider a node as a reference node, then the resistance, the voltage drop or the potential of this particular node will be 0. Okay, so now how many active nodes are there? 2, node 1 and node 2, and these are the various currents and resistances which are connected in the network. Now I'll write the equation for Kirchhoff's for nodal analysis. Okay, suppose for node 1, okay, for node 1, if I consider this circuit, this for node 1, for node 1, say I1 is coming to node 1, I4 is leaving node 1, and I2 is leaving node 1. So if we apply KCL here on this particular node, it will be I1 is coming to node, so positive, I4 leaving, so negative, I2 leaving, so negative. So it will be I1 plus I4 plus I2. I1 is divided into I2 plus I4. So I1 is equal to I4 plus I2. Now what is this I1? See, here is a voltage source and the current direction is this. So current, it always flows, always remember, current always flows from higher potential to lower potential. Okay. So current is flowing from E1 to node 1. That means E1 must be at higher potential and node 1, the voltage at node 1, that is taken as VA. So this will be at lower potential. So if I want to find out the current I1, it will be what? Current is what? It is voltage by resistance. So what is the voltage drop here? See, initially the voltage was E1, and after coming here it has dropped by an amount of to a number of VA. So it will be E1 minus VA divided by R1. See, I1 R1 is equal to E1 minus VA. So I1 will be equal to E1 minus VA divided by R1. Okay. Same way, if I consider this branch, what is I4? I4 will be equal to, see, current direction is this. So I4 will be equal to VA minus, this is at 0. So no need to write it. VA divided by R4 will be I4. See, VA is I4 is VA divided by R4. Similarly, if I go for this node, it is VA minus VB divided by R2. So I2 will be equal to VA minus VB divided by R2. Okay. In this way, we found out the value of I1, I2, I4 in terms of the other parameters. This is for node 1. Okay. Similarly, we'll write equation for node 2. Okay, for node 2. Now see, at node 2 again, I2 is coming, I3 is coming, and I5 is leaving. Okay, so these two will be positive, this will be negative. So we can say I5 is equal to I2 plus I3. Okay. Now what is I2? I2 is equal to VA minus VP divided by R2. And I3 again, this is at higher potential, this is at lower potential. So it is E2 minus VA divided by R3. That will be I3. And for this particular branch, it will be VB by R5. So see here, I5 is equal to VB by R5, VB by R5. I2 is equal to VA minus VB divided by R2. VA minus VB divided by R2. And this is E2 minus VB divided by R3. So this way we wrote two equations for the two nodes. Now see, these equations are written to find out the value of some parameter, that it can be current, it can be voltage. Usually nodal analysis is used to find out voltage. Okay, it is applied to find out voltage. Suppose the other things are known, suppose we need to find out the voltage at node 1, that is VA. So VA we can find by, suppose VA we need to find and VB we need to find. Okay, these two voltages we need to find. If the other parameters are given like E1, R1, then R4, R5, R3, R2, all these things, the values of all these parameters, if they are known, we can put here and we'll get two equations in terms of VA and VB. So if we are asked to find out the voltage at VA, then we'll solve the two equations and find out the value of VA. Similarly, if VB is supposed to be found out, then we can put the equation, put the values in the equations, solve the two equations and find out the value of VB. So in this way, we can find the voltages at VA and VB. This just I am giving an example. It may happen that you need to find out some other parameter. But if just I'm giving an example that if we are asked to find out VA and VB, then how to find it? So we'll put the values here and we'll put the values in this equation. We'll solve both equations and we'll get the values of VA, VB or whatever is required to find out. So this is how nodal analysis is applied. Now another important method which is used is Maxwell's loop current method. Maxwell's loop current method, it is the application of KVL. Okay, the previous one was application of KCL. This is application of KVL. In this method what we do, if a number of meshes are there, we consider a single current flowing in the complete loop. Single current flowing in this complete. Suppose if I describe with the help of this example, there are how many meshes? There are three meshes. Okay, this one, and this one. Suppose this is mesh 1, mesh 2 and mesh 3. These three currents are there, these three meshes are there, and suppose I1 current is flowing in mesh 1. Again, this direction depends upon you, which direction you want to take. This is just an arbitrary direction given. You can take based on your own convenience, there is no problem. So I am taking in the clockwise direction. Say it is I1, I2 and I3. I1 flowing in mesh 1, I2 flowing in mesh 2 and I3 flowing in mesh 3. Now how do we write the equations to solve? Suppose for loop 1, okay, suppose for loop 1 or mesh 1, okay, for this loop. See, current is flowing in this direction, the clockwise direction. So what is the drop happening in individual resistance that we will see? Suppose E1. What is E1? E1 is the voltage source, potential of the voltage source. So it is E1. It will be in direction, see the direction, it is rising potential. So it is plus E1. Okay. Now come to resistance. Resistance always drop is there. So it will be minus. Drop, how will we find out? I1 into R1. So it will be minus of I1 into R1. Now comes this branch. See, in this branch there was a single current flowing. In this branch, in this particular branch, part of the branch, single current I1 is flowing. But in this branch, the impact of I1 as well as the impact of I2 will be there. Okay, because this I2 will be flowing through this and this I1 will be also flowing through this. So there will be an impact of I2 and I1 both. Now since I am considering this branch, so here I1 will be dominated, and if I consider that direction of current will be this. So direction of current was this. So it will be I1. In opposition we are getting I2. So it will be I1 minus I2. Current flowing in this branch is I1 minus I2. Since I1 is coming from here, I2 is going from here. So both are in the opposite direction, so it will be I1 minus I2 into the resistance R4 will give the drop of this particular resistance, R4 into I1 minus I2. The summation of all this will be equal to 0, that is the application of KVL. Okay, so on solving this we will get this equation for loop 1. Okay, now for loop 2. Suppose I am starting from R2. Now see, in R2 only one current is flowing, right? Only I2 is flowing. No other influence of other current is there. So it will be minus of R2 into I2. Minus of I2 into R2. Now see again here, the impact of I2 will be there and the impact of I3 will be there. Now again directions are opposite, so it will be I2 minus I3 into R5. I2 minus R2. I3 into R5. This is the drop occurring in this resistance. Now come to this part. Here I2 was flowing, and in opposition we are getting I1. Okay, mind the direction. See, I2 I am considering for this loop, so I will take my direction as positive. So I was going I2 with current I2. In opposition I am getting current I1. So the net current will be what? I2 minus I1. So it will be I2 minus I1 into the drop R4. So minus of R4 into I2 minus I1. After solving this, we will get this equation, and we can find this is for the loop 2. Now again come to loop 3. Here again I will start with R3. So it will be I3 into R3, I3 into R3. Okay. Now here see, drop in potential is there from higher to lower. So it is minus E2. Minus E2. Again when I come here, I was going with a current I3 and I am getting I2 in opposition. So it will be I3 minus I2. Net current will be what? I3 minus I2 into the resistance will give the drop occurring at this particular resistance. So it will be I3 minus I2 into R5 is equal to 0. The summation of all this will be equal to 0. Again, that is the application of KVL. After solving this, we are getting this equation. Okay. So we are getting 3 equations for 3 loops, 3 equations we will get. So if we are asked to find out current flowing in any particular resistance, then we can easily solve the 3 circuits and find out the current which is required to be found out. If we are asked to find out the current flowing through R1, we will calculate the value of I1. If we are asked to find out the value of R4, we will calculate the value of I1 and I2 both, and the result in the net current we will find out which is flowing through R4. Now for R2 we can calculate I2. For R5 again we will find out the net current, that is I2 minus I3. Okay, and for this I3. So this way Maxwell loop current method is applied. Again this method is very important in solving DC networks. Not only DC networks, it is applicable to AC networks as well, but since this is the module of DC networks, so I will stick to DC network only. So for these 3 networks, we will get 3 equations, and we can solve all the 3 equations and find out the value of the current or the voltage drop, whatever is required to be found. So again it depends upon you which method is suitable, which method you are convenient with for solving a particular network. With rigorous practice, you will understand, or you will realize yourself which method will be best suited for solving a particular problem. So the problems related to these 2 methods and KCL KVL as well, I will discuss in the coming lectures. But today, I will stop up to this only. In the upcoming lectures, I will discuss some problems related to this. Not problems. So I will discuss some numericals used solve for and use these methods for solving those numericals. KCL KVL. Then if I talk about application of current method and the nodal analysis method, those I will apply and solve the circuits, DC circuits. So that we will discuss in the upcoming lectures. So for today I will stop here. Thank you for your patience and time.